Hello, everyone. My name is Tomas, as said. I'm part of the Institute for Advanced Architecture of Catalonia in Spain. I'm an urban designer. I studied about cities, and I'm going to talk about the implications of digital fabrication in the future of these cities. And I also will try not to say the word maker during my presentation. I'm interested in the relationship between city, society, and technology, and how they have been affecting each other during time. If you look back in time, you can understand that cities have been created or have been followed by the available technology and also by the cultural changes. That's why the Roman Empire actually grew thanks to the existence of a kind of a menu on how to develop a new city and also the technology to construct it. No? Then later on, if we jump a few thousands later, I'd like to stop in a moment in the history where medieval cities were actually concentrating a lot of knowledge within its walls. But then a significant technological change happened, which was the invention of a printing press and caused, let's say, a massive exchange of knowledge and then for the consequences. I think this is better explained by this video. So if you think on the effects that the industrialization had in the cities, you can look now that we have been listening during this morning on how, let's say, the right path of a product is to get to mass production, right? So yeah, we created the technologies to produce massively something, to repeat things thousands of millions of times also. And by the way, this is not a city, this is actually the tooling that you use for plastic injection to repeat for the production of speakers that we buy in stores. So we extract raw materials. We are causing some significant, let's say, damage in the environment. We have people producing things for us. They do a repetitive job for many hours a day, again and again and again. There's no creativity in that process. Those things are shipped where people buy things. They use them. Those places are cities, basically, and then they are turned into trash. We usually, or most of the time, we don't actually reuse it. No? So this is the model that we have created somehow. No? We extract things from one side of the world, we ship it some other places, like Shenzhen. We produce a lot of things that are shipped back into the consumption centers, and then they are turned into trash, and this trash, as I said, is not reused. This has a high cost on energy use, of course. And actually, we were talking yesterday with someone from this massive factory, and sometimes even the things that are manufactured from China, they come back to China because there is a demand of the product in China, which is really interesting. No? So we use a lot of shipping containers to do that. What happens, it's not only about the energy resources and so on, but there is like a social consequence of killing creativity. So I think that these questions have been, have been raised during all this week in Shenzhen, and also all the efforts that are being made are trying to change somehow this, not to have just workers that do a repetitive work every day to buy things, to turn it into trash again and again and again. So basically, as I said, I'm interested in how technology can change society, and somehow has been doing it during the last 70 years or so. If you think about how computation and internet are being entered into our lives, we're getting into limits today in which we're having more in parallel both a physical and a digital life, and even the newborns will be more used to that than us. For that, we created tools that have allowed us to be producers of information. So if you go back maybe 20 or 30 years in the history, you would go to a conference like this, and there might be 2 photographers, let's say. But now each one of you is a photographer and also can broadcast the information in real time to the world. And this has happened in the very, very, very quickly, let's say. So this is the St. Peter's Square in Rome when the Pope is elected, and only in 8 years you see the differences of the inclusion of technology in our life. Sometimes we use it in a very insignificant way, so actually to feed sometimes our ego or present in digital platforms, but sometimes can be useful to change society, even to change politics somehow. No? So we live in a connected world. Cities are connected by these submarine wires that it's called the internet, and also satellites connecting GPS. No? So as I say, personal computation, real-time communications, internet and computers, mobile phones, etc. What happens if we add something new to that formula? This is where it comes digital fabrication. This is something that many people is called a new industrial revolution or the third industrial revolution, right? So what happens, we're talking about something that is basically almost a reality. There are fab labs everywhere in the world, and you can actually have access today to places that you can make almost anything. So let's talk about fab labs. Fab Lab stands for Fabrication Laboratory. There are small-scale workshops equipped with digital fabrication machines. In these places, you can find people that know how to make almost anything.
There's a new generation that's not waiting for top-down solutions. And so the people starting Fab Labs and linking them, I see them as creating a new notion of an economy.
The Fab Lab Network is a community of people who want to collaborate and share knowledge. Fab 11 is our rare opportunity to gather in person and share that knowledge and our experiences in deep and meaningful ways.
If you look from the outside at what is happening in what we generally call the maker movement, there is one thing that's outstanding with Fab Labs, and that's diversity and inclusiveness.
What's striking is not the differences but the similarity. They're used in the same ways all around the world. They're used for a mix of play, research, work, education, invention, and the people they attract look very different. They come from very different places, but they're all kind of the same.
So the Fab Lab stands, as the video says, for Digital Fabrication Laboratory. Each year, the Fab Lab community gathers in a country in the world. This summer is going to be in Boston. And these people share knowledge, technology, and a vision of how the world would change when digital fabrication becomes accessible and common for everyone. But usually when I go to many places, I try to explain people what Fab Labs are. And then I ask them, what do you think Fab Labs are? So this is the kind of things I get from them. They're pretentious, cool nerds club. People say that Fab Labs are elitist, closed spaces. People also say that it's only high-level science and technology, that we only care about technology. People say that, you know, Fab Lab people is MIT groupies, no? So, and also, this is related with everything, it's expensive machines in universities, which is I mean, all of this is partially true, I have to tell you the truth, to be honest. So, but the thing is that the reality is that the Fab Lab is more than that. It's a space where, yes, there are machines, there are processes that has a meaning. The idea of having digital fabrication machines is because we can ship data to make things. That has a meaning. You cannot ship the plans to make an object if you don't have the means to make that object, right? So that's why we use these machines. But it's about people. It's about connected people using the internet, sharing projects, sharing programs somehow. And the kind of things that you can see in a Fab Lab, they vary depending on the context and the culture that you will find in the more than 540 Fab Labs that are today in the world. And we have a fast-growing network in China, led by people like David or by Eric, let's say. So what Fab Labs are, I mean, what we are trying to do, we try to provide access to tools. This is the other part of the story, to anyone, right? It's trying to make MIT obsolete. This is the truth. It means that if you want to go to MIT, you don't need to go to MIT. You can actually go to the Fab Academy, have access to your Fab Lab in your country, and then have the access to the content that you can find at MIT and share with colleagues that have the same knowledge. It's about changing education, the way kids learn, and learn science, technology. This is partially what the previous speaker was talking about STEM or STEAM, by using digital tools and digital fabrication tools. It's changing the production model. If in a Fab Lab you can make almost anything, then you can make the things that make almost anything. And this is a project we kickstarted here in Shenzhen, and probably in 1 year, and hopefully in 1 year, we're going to be introducing the Fab Lab 2.0, which is a Fab Lab that can make another Fab Lab. So self-replication comes into Fab Labs. So it means more access, it means cheapest machines, and means more inclusiveness, hopefully. So making policymakers to make, and this is an experience that I can personally talk about, is in Barcelona, we committed the mayor to actually launch a challenge which aims to turn Barcelona into a self-sufficient city in the next 40 years. And by providing digital fabrication tools, that's one part of the story, let's say. And then it's mainly about shipping data and not things. It's not about killing China's economy. It's actually trying to create a fair access to production means for anyone in the world, not being dependent on centralized production models. So it means to create, let's say, the infrastructure to reindustrialize cities and actually being able to reduce, on one hand, the environmental impact that we have in the current existing model, but actually providing people the access to knowledge to make things, which is quite important. I want to talk about a little bit about the work we do in Fab Lab Barcelona, which is where the Fab Lab I run with colleagues since 2007. It's inside the Institute for Advanced Architecture of Catalonia, so we work a lot in architecture and design at different scales. So we do education through master's programs, we do research through special projects, and we do production for actually projects in the real life, and I will show some of them. So when we talk about education or research, let's say the kind of architect that we are training is the architect that is not only designing buildings, but actually designs the means to make the buildings. This is a project called Fab Clay, in which the architect or the student behind the project never designed the building itself, but designed the tool that goes into the robot, and also played with the materials composition in order to build 3D structures. This is a flagship project that we developed in 2010. It's a Fab Lab house. It's a full house that you can actually download from our site and make it in your Fab Lab if you have time. It's a house that can produce energy to satisfy its own needs, but actually can also it produces extra energy that can be shipped, sent back to the network. So this is linked to a project that we are developing that is called EnerGrid, which is the Internet of Energy. So we think that as we exchange bits today that contain information about a picture or about a video, you can change also watts or kilowatts with your neighbors, and basically change a cup of coffee for powering your TV tonight. So these are some of the projects, as I'd say. So we range in the scale of architecture mostly, but on architecture understood from different levels. I mean, we play with the materials that actually are the components of in the construction process. We think about the tools that make those materials or to process those materials, and also we think about the design and how the energy affects the design and so on. For instance, these are 4 projects. This is Mini Builders. It's a project about robots that can make things that are bigger than themselves. So this is, with 3D printers, you cannot make things that are bigger than the 3D printer. But with robots synchronized between them, that you can do it. This is another project called Material, which actually you can, is anti-gravitational 3D printing. So it means that you're not depending on gravity to 3D print something. And these are 2 pavilions that we have made with an electricity company called Endesa, and it's totally digitally fabricated architecture space, and there have been demonstrators of smart grid projects from this electrical company in Barcelona. So yeah, we play a lot with architecture, but not only with architecture, as I said, in the scale of a building or materials, but there are projects at the Fab Textiles, which is in the world of wearables, but not only understood as something that you can put in your wrist, or something that you can actually, or sensors that are embedded in your body, but actually using digital fabrication processes to make a different garment. No? 2 projects that actually relate with another scale in this case is the Smart Citizen project, which is a sensor device that we developed in the Fab Lab during the last years, which aims for people to produce information, relevant information about cities. And this is something that, cities are a big challenge today, and they will be the big challenge for the future. They're going to be overpopulated. More than 70% of people will live in cities in 2050. And then we have big challenges, as I said, and you know a lot about this. Pollution will be increased and so on. So we thought about this, and we thought that we can not only think about monitoring the cities is a task of the government only, it could be also done by citizens. So you can report the environmental conditions of your street, of your public space, by using low-cost sensors. In this case, we developed the Smart Citizen Kit, which is a low-cost device that contains environmental sensors that they can capture information from your environment, and then can be uploaded into a website, and then in this website you can see, share, and understand what has been happening during the last weeks, months, year in your street, and how things are changed depending on the activities that are performed in the city. If you want to look more, you can go to the site that is there. But I want to continue in a change of scale of a type of projects that we develop in the Fab Lab. And this is not only about fabricated stuff, but also about the implications of digital fabrication. No? And in this case, how it's going to affect society, and how it's going to be these cities in which there are people that can make their own things. What happens if you don't, what is the meaning of work? What is the meaning of time when you can make the things that you need and you don't have to work in something that you don't like to buy things that you want, but actually you can use your time to make the things that you want. No? So these are the questions that we have around the Fab City project, which we kickstarted in 2007. And this is basically has been mostly a political move. So it's how digital fabrication gets political. These 4 guys this is the mayor of Barcelona. He's not the mayor anymore this year. He stopped being the mayor this year. But this guy is the founder of the Institute of Architecture where the Fab Lab is, and this guy as well, and this guy as well. So he became the chief architect of the city of Barcelona. He became the director of Urban Agency of Barcelona, and he became the deputy mayor during the government of this guy. So we used this political power to launch, let's say, the Fab City project with the idea of bringing back from manufacturing to the users, no? Which is not that different from a high-tech medieval age, if you think about some parallelisms in history. In the medieval cities, we were used to make all the things that the city needed. So it's somehow a high-tech version of that. In which there is a public network and private network of Fab Labs that are providing access to people to learn and make, but actually connected to industry. And beyond that, it's actually building an ecosystem, not only a city of fabless, but a city of many things that are happening around digital fabrication and how they can be complementary between each other, which is really, really, really important. So this is basically changing how economy works. If you think about the linear economy that we are today, we basically have, even in the process of creating a product, is very straightforward. While if you think in circular or spiral terms, you are creating products that they don't have an end of life, for instance. You have a city that reduces its trash. You have, let's say, maybe an economy in which money is not, it's not actually the currency that makes it work. So these are the things that might be affected by the introduction of digital fabrication tools into the future. And hopefully it won't happen similarly with what happened with internet in the 90s, that actually created a more aggressive capitalism. But maybe there is an opportunity to create an alternative to that. And I'm not a communist. So basically what we are changing is actually the model of production of the world, and trying to go from a centralized production model to a distributed one. And that means more access to people to produce. You can call it as you want, but I think that's it. Thank you.